Alright guys, so we're gonna do 8.1. So let's start with the first one. The resulting figure after transformation has occurred is called the image. Yes, so we have the pre-image and then we have the image. So the image is, I guess you can consider it like the post image, but we don't call it that. We call it pre-image and then image. Okay? So there's that. Now, tell whether the transformation appears to be an isometry. For something to be an isometry, it needs to be congruent, just with a different orientation. So if we look here, this figure looks exactly like this one, just that this one is slanted and this one's slanted like to the right and this one's slightly slanted to the left. So we see here that what happened was a rotation of some kind, a rigid transformation, and that's what this chapter is all about, rigid transformations. So remember that the rigid transformations include rotation, reflection, and translation. Okay? The one that is not a rigid transformation is the dilation. Okay? So if something rotates, reflects, or translates, then it is an isometry. It is a rigid motion. So no, that's not true. No, that's not true. Yes, because the angle measures and or the distances between the vertices. That means this, which is pretty much, guys, the distance between vertices is just the side length. Are not the same? No, they are the same. So our answer is D. Yes, because the angle measures, which is this, whatever these guys are, and the distances between the vertices are the same as the corresponding angles, measures, and distances of the pre-image. So that means all of this, the angles and sides, are the same as this. Okay? So in the diagram, the smaller triangle is an image of the larger triangle. So since it said the smaller angle is the image of the larger one, that means that this triangle is the newer one. This is the pre-image and this is the image. And we also know that because of these prime marks. These little marks, these little apostrophes are called primes. So Q is the pre-image of Q prime. Line segment PQ, this one, and PQ prime. What's it asking? Name the angle in the image that corresponds to Q in the pre-image. That's A. And list all pair of corresponding sides. So PQ, yeah, so AQ is to Q prime. Line segment PQ and line segment P prime Q prime. Line segment PR, line segment P prime R prime, and so on and so forth. That's it. So now this is pretty, this one's not bad. Identify the single transformation, whether it's translation, reflection, or rotation, from the pre-image to the image. So from here to here, what happened? We had to rotate it. So our answer is A. From here to here, we had to translate it. So our answer is B. And from here to here, we had to just reflect it across this line. So it went like this. Did a flip. That's called a reflection. Okay? Once again, same thing. From the pre-image to A, it looks like it was just a translation. It just went up and then to the right. Here, it looks like a reflection. Yeah, it probably reflected over this line, and it just reflected. And now from this guy to this guy, it looks like I had to rotate around this way. Okay? Now let's look at this one. Use the diagram to the right to complete the following mapping statement. The mapping is an isometry. Okay, that's important. That's saying that this is obviously the image. This is the image. So they want to know what was the, yeah, they want to know this, whatever this is and this are going to be the exact same thing. How do I know that? Because it's an isometry, which means they're going to have their angles and their side lengths congruent. It's going to be the same. Okay? So, which one's the one? So we want PRQ. Where's PRQ? PRQ is right here. PRQ. So we want the figure, either this one, this one, this one, or this one. We want to see which one is the isometry of this guy. Well, I know that PRQ has angles of 67 and 34. So automatically, whatever does not have angles of 67 and 34, I can automatically take it out, right? So 67 and 34. Okay, so this guy's gone, this guy's gone. And now this 5 meters also has to be between the 67 and the 34. So the only one that's acceptable is this guy. So now it's X, Y, Z. But remember that we have to go in the correct order. So if this one's PRQ, that means what is P? The P has no angle. So we have to start with one that has no angle. So we got to say Y. Now PR 67, X is the 67, and then Z, Q is 34, and then which one's 34 over here? The Z. So it's YXZ. So my answer is F. This one. If the transformation to the right is an isometry, find the value of A. Well, we just talked about this. This is obviously a reflection that's happening. This is a reflection, so that means this is going to turn into that, but it's going to flip. So that means this guy, this is going to be equivalent to this. This is going to be equivalent to this. This angle right here is going to be equivalent to this angle. So what is it that they actually want us to find? A. So this guy is going to be equivalent to this guy. So what's my A? It's 12. That's it. Okay. If the transformation to the right is an isometry, find the value of Y. Once again, we're doing the same thing. So what we're doing here is we're rotating it. We're rotating it. So what is Y? This little angle right here. So if I were to rotate it this way, what would be the angle? This 30. So now all you got to do is set 3Y equals to 30, because we just said that they're both equivalent. They're both the same thing. They're both congruent. So divide by 3 in order to find your Y, and your Y is 10. Okay, so that's the first one.